welcome to today's video. Today's video is about the substitution of ligands around copper complexes. Now, the ligands in a complex can be exchanged either wholly or partially for other ligands, and this is a type of substitution reaction. It happens if the new complex formed is more stable than the original complex. So at this moment in time, we've got some copper-2 sulfate dissolved in some water, and the copper-2 ions and the sulfate ions have separated out. They've dissolved completely. You can see it all the way through. It is transparent. But the copper-2 plus ions are what we are interested in right now. The copper-2 plus ions are surrounded by 6 water molecules that are donating electron pair density into copper-2 plus ions, and that's what keeps them stable. You can see all the way through it, and that is because each of the copper-2 plus ions that are in this solution are actually stable and surrounded by 6 water molecules that are donating their electron pairs into the copper-2 plus ions. Now, we actually give a name for that. We call that ligands, and the ligands in this complex that you can see in front of us can actually be exchanged either wholly or partially for other ligands. So I've got some sodium hydroxide that I'm going to be adding into the solution. You can actually see immediately something new is forming. So the sodium hydroxide contains sodium ions, but the sodium ions don't really participate in any way whatsoever within the reactions that you see in front of you. It's actually the hydroxide ions that are substituting themselves for the water molecules that were around the copper-2 plus ions. This is a type of substitution reaction. It happens if a new complex is formed that is more stable than the original complex. So you can actually see that it's forming a layer that is not soluble. I'm going to give it a little stir to demonstrate that. I've got my glass rod. As I put it in and give it a gentle stir, you can actually see that it is not dissolving. And it's a blue precipitate, blue solid. Here's a lovely close-up of that precipitate. You can see that it's starting to settle at the bottom of the boiling tube, and it simply won't dissolve. So it's turned a lovely light blue colour now, and basically what has happened is that 2 of the 6 water ligands around each of the copper-2 plus ions has been replaced by 2 hydroxide ligands in this chemical reaction. So we've got this pale blue precipitate, but now what we're going to do is we are going to add some ammonia solution. Now, ammonia is going to interact further with this precipitate. So I'm going to add the ammonia dropwise. Now, 4 of the ammonia molecules are actually going to participate in this ligand exchange. And what we're going to then see are 4 ammonia molecules paired up with 2 water molecules around each of the copper-2 plus ions. So you should be able to start to see a significant color change. This is because the ammonia is more stable around the copper ions. So as there always remains 6 of these ligands around the copper-2 plus ions, we can say that the coordination number around the copper-2 plus ions is 6, and it is a 3-dimensional structure. The 3-dimensional structure that forms is an octahedral shape. And now what we're going to do is we're going to give it a stir. So you can actually see both layers are now starting to mix at the interface. And we're starting to find that the light blue precipitate
is dissolving. And this is because more and more ligand substitution is taking place.
And you should now start to be able to see all the way through the solution. So you should be able to now see all the way through, because the new complex is soluble in water. So let's just summarize what we've just seen. In the first reaction, we have 2 water ligands that are replaced by 2 hydroxide ligands in the reaction. And then when we added ammonia solution, the pale blue precipitate dissolved and we got a deeper blue solution because we substituted the 2 hydroxide ions as well as 2 of the water molecules for 4 ammonia molecules. That formed a deep blue solution because our complex regained its charge. Thank you very much for watching.